Hello, Algebra, and welcome to the final part 3 of our absolute value many-topic lesson series we're going to call on piecewise defined functions. And we typically just call these piecewise functions. Okay, this piecewise defined is new to us, but there you go. So what a piecewise defined function is, or a piecewise function, is where you have different rules, or in this case functions, for different intervals of its domain. Not it is, of its domain. Sorry about that. Of its. English teachers might have a cow. And again, when we talk about the domain, we're talking about the x values, the x's. So I want to draw an absolute value function. Right, this follows the absolute value functions section. So here is my coordinate plane for an absolute value. Remember, we're going to put 2 in each direction, here, here, and here. Your vertex is at 0, 0. Then you have 1, 1, and 2, 2. There's the right-hand side. And then you have negative 1, 1, and negative 2, 2 over here. And the reason that this section, again, this is a absolute value function, y equals absolute value of x. The reason this is related to piecewise functions is because this is really a piecewise function. We have 2 different parts of lines, part 1 and part 2. So what I'm going to do is I'm going to come down here and I'm going to define a piecewise function, and I'm going to put this brace. And I'm going to have 2 functions, so one up here and one down here, with its own domain. So on this left-hand side, this is a negatively sloped line. So its slope is equal to -1 because you go down and to the right. And then its y-intercept is 0 because it goes to the origin. So this is just the equation -1x or -x plus 0. We're not going to put that. So that's a line, -x. And we're going to say that it is defined if x is less than or equal to 0. So that's going to count. That's going to include the vertex and everything to the left. All right. Then this right-hand side has a slope of +1 and a b value of 0 because it goes to the origin. So this would be positive x if x is, and we're not going to say greater than or equal to 0. We're just going to say greater than 0. Right? We're going to leave off where we left from up here. So up here includes all the negative numbers and 0. This one includes all the positive numbers. And between these 2 pieces, we have created the entire function across the entire domain from -infinity to infinity. So this is what we mean by piecewise functions. 2 functions making up one picture. So let's do one on the next slide here. Okay, so we're going to graph this piecewise function. So again, if you look here, these are the functions. So your first function is f of x equals -x. The second function is f of x equals 2x plus 3. And again, they are defined over parts of the domain. So these guys right here with the x's, those are your parts of the domain. So if we look here, right, so domain, this says x is less than or equal to -2. So this is going to be the left side of the graph. And because it's equal to, it's going to have a solid dot. And over here, where it says greater than, this is going to be the right side of the graph, and it's going to have an open circle. And we'll talk about that when we graph. Okay? So what we're going to do here is we're just going to graph each function separately over its specified domain. So this will be my first graph. This will be my second graph. So first graph, f of x equals -x, right? So what we're going to do here is we're going to take this domain value of -2, and we're going to plug it into the function. So f of -2 equals -2, the opposite of -2, which is +2. So this gives me a point, and that point is -2, 2. X is -2, y is 2. And this is going to be a solid dot. So on my graph, I'm going to find -2, 2, and put a solid dot. And now again, we are going to now graph everything to the left shift to the left of that line. So now we're going to look at these in slope-intercept form equation, right? This is negative 1x plus 0. So your b value is 0, and your slope is a negative 1 over 1, which would be down 1 and to the right 1. Now, I'm not going to go down and to the right because that would be the wrong side of my graph. So I'm actually going to go up and to the left. Up and to the left, up and to the left, up and to the left. And this is going to give me the left side of my graph, this part of the piecewise function. All right, so now we'll do the second equation, the second function. So f of x equals 2x plus 3. I'm going to plug in negative 2 again. Again, I'm going to plug in negative 2 into this function. So f of negative 2 equals 2 times negative 2 plus 3. Again, use a graphing calculator or Desmos, whatever you want to do to simplify this, but that's going to equal negative 1. So this point is negative 2, negative 1, and that'll be an open circle. So I'll go to negative 2, negative 1, an open circle. Notice that these 2 points are vertical to each other, and that's because they use the same x value, right? This is when x is negative 2. Notice, though, that one is solid and one is open because there's that thing called the vertical line test for functions, and if these two are both solid, it would not pass the vertical line test. So one has to be solid and one has to be dotted. Again, you cannot include negative 2 over both of the functions. And now, if we look here, for this one, the b value is 3, and the slope is 2 over 1, which would be up 2 and to the right 1. Now, what we can do is we could just use this b value, right? We're lucky enough that we can just go up 3. And here's my 2 points. Now, again, you could always count the slope of up 2, right 1, up 2, right 1, up 2, right 1 to get a good graph. But you could just use that b value and the starting point and connect the dots. And that would be the right side of this graph. And this would be the piecewise function. Now, what would be the overall domain of this function? Well, notice you have arrows here and here. Arrow here, arrow here. So this includes everything to the left, everything to the right. So this domain would be all real numbers. Again, that's negative infinity to infinity with parentheses. And then the range here, so if you notice here that this is the lowest point on your graph, right? That has a y value of negative 1. Notice it cannot be negative 1, so our inequality would be y is greater than negative 1. It could be anything up here. I know there's this gap here, but all these y values are filled in on the blue, and then the red and blue both go up. So that would be the domain in inequality notation, or the range in inequality notation, and then the range in interval notation would be from negative 1 with a parenthesis all the way to infinity because we're going up. Okay, so there's the first video. Second video for piecewise functions is coming up next.